Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic relations, mapping and functions. In the previous video, we learned how to find the rule of an exponential mapping. In this video, we are going to learn how to find the rule of a mapping that is neither exponential nor linear. Finding the rule of a mapping by inspection. Sometimes, a mapping may be neither linear nor exponential. In such a case, the rule can be found by inspection. Let's pick an example of such a mapping. Look at this example. You can see from here that the common difference between elements in the domain. Let's look at that. 3 minus 0 will give us 3. 5 minus 3 will give us 2. 7 minus 5 will give us 2. And 9 minus 7 will give us 2. So between these consecutive elements, between 3 and 5, between 5 and 7, between 7 and 9, the difference is 2. But between 0 and 3, the difference is 3. So it is not the same. For a linear mapping, we know that the difference between all of them consecutive elements must be the same. Let's come to the codomain. Between 0 and 6, the difference is 6. Between 6 and 10, the difference is 4. Between 10 and 14, the difference is 4. Between 10 and 18, the difference is 4. You can see the difference between 6 and 10, 10 and 14, 14 and 18 are constant. But the difference between 6 and 0 is 6. So this is not linear, because for linear, the difference between consecutive elements in the domain and difference between consecutive elements in the codomain are all the same. So here, difference between consecutive elements in the domain, if it was linear, they were all supposed to be the same. The difference between consecutive elements in the domain here, if it were to be linear, they were all supposed to be the same. So we are certain that this is not linear. Let's check and see if this is exponential. For exponential, we are saying that the common ratio between consecutive elements in the codomain must be the same. So let's check. 6 divided by 0 is 0. 10 divided by 6 will give us 10 divided by 6 will give us 5 over 3. So clearly we have seen that 0 and 5 over 3 are also not the same. 14 divided by 10 will also give you something different, and 18 divided by 14 will also give you something different. So you can see from here that this is neither linear nor exponential. Let's look at another one. So here, elements in the domain are being described by A, elements in the codomain are described by B. Let's check here. You can see that between 0 and 1, the difference is 1. Between 1 and 2, the difference is 1. Between 2 and 3, the difference is 1. Between 3 and 4, the difference is 1. So here, the common difference between elements in the domain are constant. Let's check and see for the codomain. Between 1 and 0 and 1, the difference is 1. But between 1 and 4, the difference is 3. Between 4 and 9, the difference is 5. So you see, it keeps changing. For it to be linear, the difference between the consecutive elements in the domain must be the same. Difference between consecutive elements in the codomain must also be the same. So this is not linear. Let's check and see if this is exponential. For exponential, the common ratio between consecutive elements in the codomain must be the same. So let's try. 1 divided by 0 is 0. 4 divided by 1 is 4. 9 divided by 4 will give you 9 over 4. So you can see from here that the common ratio between consecutive elements are also not the same. So this is also not exponential. So in both cases, the mapping is neither linear nor exponential. So how then do we find the rule or the formula? This can be found by what you call inspection. You inspect the elements in the mapping. How do you do this inspection? Let's pick some examples and see how this is done. Find the rule of the following mapping. So let's pick the first one. This was the example that we were considering in the previous video. We are certain that it is neither linear nor exponential. Once again, when the question is given to you to find a rule, they are not going to tell you this is linear, this is exponential. No, you have to check for it. We have checked this from the previous slide and we have seen that it is not linear, it is not exponential. So we are going to find a rule by inspection. So let's inspect. By inspection, you see, if you take the first element in this image, 0 and 0, you can't draw any meaningful conclusion from 0 and 0. So let's pick the next one. We have 3 and 6. The next one, we have 5 and 10. The next, we have 7 and 14. The next, we have 9 and 18. Now, if you could see, if you look at this very, very carefully, you can see that to get the image 6 here, if you multiply 2 by 3, we are getting the image 6. To get the image 10, if you multiply 2 by 5, we are getting 10. To get the image 14, if you multiply 2 by 7, we are getting 14. If you get the image, to get the image 18, if you multiply 2 by 9, we are getting 18. Now you can see a common pattern is repeating itself. Even if you pick 0, if you multiply 2 by 0, you are getting 0. So a common pattern is repeating itself. You multiply 2 by the elements in X and you are getting the image. So if you take this element here, you multiply it by 2, you get this. If you take this, you multiply it by 2, you get this. If you take this, you multiply it by 2, you get this. If you take this here, which is 9, you multiply it by 2, you get 18. So something is repeating. There's a common pattern. What this tells us that if you want to get Y, all we need to do is to take X and multiply it by 2, or multiply 2 by what you have in X. So the rule is Y is equal to X times 2. It is very simple, right? By inspection, we are able to see this. If you want the image, which is Y, all you need to do is to take X and multiply it by 2, because that is what we have been seeing. So if the next one is 10, or maybe if the next one is 9, if the next one is 11 or 12, all you need to do is to multiply that with 2 and you are going to get this. We saw this by inspection. That is why we say that we are doing it by inspection. So the rule is Y is equal to 2x. Let's look at the next one. We have the mapping. This time the elements in the domain is described by A, elements in the codomain is described by B. Now let's look at this very well. A maps onto A, 0 maps onto 0. As I said, it's usually difficult to draw conclusions from 0 mapping to 0. So let's consider the next one. Here 1 maps onto 1. That is also quite difficult. Let's pick the next one. 2 maps onto 4. 3 maps onto 9. 4 maps onto 16. Now look at something here. You can see that if you take 2 and you square it, you are getting 4. If you take 1, you square it, you are getting 1. If you take 0, you square it, you are getting 0. If you take 3 and you square it, you are getting 9. If you take 4 and you square it, you are getting 16. So a pattern is repeating. What you have to do is that to get B, you have to take A and square it. So here, A here is 2, B is 4. So to get 4, which is B, all you need to do is to take A and square it. So you see that by inspection, you can see that 1 is equal to 1 squared. 4 is equal to 2 squared. 9 is equal to 3 squared. 16 is equal to 4 squared. So there is a pattern repeating. There's a pattern repeating. And the pattern is that if you want B, all you need to do is to take A and square it. So this is the rule of the mapping. B is equal to A squared. So whenever you are being given a mapping that is not linear nor exponential, all that you have to do is to study the mapping. Inspect the mapping, and you can see that there is a common pattern. Use that pattern to form the rule. And here the pattern is that if you want the image, which is B, take the element and square it. So if you want the image of 2 here, it's going to be 2 squared, which is 4. The image of 3 is going to be 3 squared, which is 9. The image of 4 is going to be 4 squared, which is 16. So the image of 5 is going to be 5 squared, which is 25. Image of 6 is going to be 6 squared, which is 36. So the order continues. So we have been able to find the rule of this mapping. Let's look at the next example. The mapping has been given to us here. Elements in the domain are described by X. Elements in the codomain are described by Y. Let's find the rule of this mapping. Now, by inspection, it can be seen that both the numerators and the denominators follow the rule for linear mapping. Therefore, find the rule for the numerator and the denominator separately. Now, this is what I mean. We are certain that this is not linear, this is not exponential. So we have to find a way of finding the rule. Now, this is a fraction. You know that fractions have a numerator part and a denominator part. So let's consider the numerators. If you consider the numerators, you can see that we have 5, 8, 11, 14, and 17. Difference between 5 and 8 is 3. Difference between 8 and 11 is 3. Difference between 11 and 14 is 3. Difference between 14 and 17 is also 3. So you can see that the difference between consecutive elements is constant, and that is follows a linear mapping. Since we are certain that the one in the domain here, difference between this one and this one is 1, between 2 and 3 is also 1, between 3 and 4 is 1, between 4 and 5 is also 1. So that is constant. Now we are also seeing that if you take the numerators, the difference between consecutive elements is also constant. So that follows linear. In the domain, the common difference is constant. In the codomain, the common difference is also constant. So that follows a linear pattern, right? So it means that the numerator follows a linear pattern. Let's look at the denominator. Difference between 8 and 13 is 5. Difference between 13 and 18 is 5. Difference between 18 and 23 is 5. Difference between 23 and 28 is also 5. So you see that the denominators is also following a linear pattern, since the common difference is also 5. So if this happens, what you have to do is that find the rule for the numerator separately and find the rule for the denominator separately. How is this done? Let's see. Rule for the numerator. Because we are finding the rule for the numerator, we are going to assume that the denominators don't exist. So the denominator is taken off. Remember, the denominator used to be there. But because we are finding for the numerator, we are assuming that the denominator don't exist. Now, this is the mapping that we need to deal with. 1 maps to 5, 2 maps to 3, 3 maps to 11, 4 maps to 14, and 5 maps to 17. Now you can see that this is a linear mapping. So we can find the rule for this linear mapping that we are seeing here. So to find the rule, we quote the general rule for a linear mapping. We know that that is y is equal to AX plus B. We have already done this in a previous video, so you know how this is done. Now what is A? A is the common difference in the codomain divided by common difference in the domain. Common difference in the codomain will be given by, in this case, I'm picking the first two elements, so 8 minus 5 divided by 2 minus 1. We have seen from previous video how this is done. So this is A. We have found A, so we replace 3 with A. So we are going to have y is equal to 3x plus b. To find b, we know that we are going to pick an element and its image, then we can use it to find b. So I'm picking the first one. When x is equal to 1, y is equal to 5. So this is going to give us 5 is equal to 3 times 1 plus b, since y is 1 and x, since y is 5 and x is 1. Sorry. So this is going to give us 5 is equal to 3 plus b, and b will give us 5 minus 3, so b is equal to 2. So we have now found b, so we can replace b with 2. So for the numerator, the rule is 3x plus y is equal to 3x plus 2. Now we are done with the numerator. Remember, we said that the denominators also follow a linear mapping, so we need to find the rule for the denominators too. So find the rule for the denominators. This time, because we are finding for the denominators, we are going to assume that the numerators are also not there. So this is the mapping that we are dealing with now. 1 maps onto 8, 2 maps onto 13, 3 maps onto 18, 4 maps onto 23, and 5 maps onto 28. Now this is an example of a linear mapping. So we find the rule of this linear mapping. We quote the general rule, which is y is equal to as plus b. A will be given by, in this case, we have 13 minus 8 divided by 2 minus 1. Then this is going to give us 5. Since 13 minus 8 is 5, 2 minus 1 is 1. So 5 divided by 1 is 1. So we replace a with 5, and this will give us y is equal to 5x plus b. Now let's find b. I'm going to pick the first element and its image. So when x is equal to 1, y is equal to 8. You replace y with 8 and x with 1, and that will give us 8 is equal to 5 times 1 plus b. This will give us 8 is equal to 5 plus b, and b will be given by 8 minus 5, so b is 3. So we can now replace b with 3. So we can say that therefore y is equal to 5x plus 3. So this is the rule for the denominator. So now we can see that we have found the rule for the numerator and rule for the denominator. So the rule for the mapping will be equal to y is the same as rule for the numerator, which is 3x plus 2, divided by rule for denominator, which is 5x plus 3. So from inspection, we saw that the rule for the numerator follows a linear mapping. Rule for the denominator follows a linear mapping. So we found the rule for the numerator, we found the rule for the denominator. So after we finish the whole thing, y is going to be given by the numerator divided by the denominator. So whenever a mapping is given to you, all you need to do is to check whether it is linear or exponential. If it's not linear and it's not exponential, then it means that you have to find the rule by inspection. Thank you for watching this video, and pick more examples on finding rules of mapping. Try your hands on these examples. Interact with me on my social media handles if you have any problems, and I'll help you to solve it. See you in the next video, where we will consider the last part of our topic, which is functions. Bye bye.